10.7, Write and graph equations of circles. This is our last and final section in Chapter 10, and it's going to take on a completely different feel today as this kind of goes back into a little more algebraic about circles and writing and graphing those, okay? So the big thing for this entire section is this first vocab, which is the standard equation of a circle. And I know right now when you look at this, there's all kinds of things on my screen. So let me first write down the standard equation of a circle. Okay, you get x minus h in parentheses squared, always plus in the middle, y minus k in parentheses squared equals r squared. Okay, and now you can start seeing these different notes all the way around. And again, if I move too fast, reverse the video a little bit, pause it, copy down what you need to. So you're always going to see this x and you're always going to see this y in every equation. You're always going to see these squareds. That's part of the equation. You're always going to see these parentheses. So those are things that will always be there. Now, I have this minus h minus k. These are different numbers in different equations, and it's always opposite what you think they're going to be. So if you see a minus here, I'm going to go right h places. If I see a plus, I'm going to go left h places. If I see a minus on the y, I'm going to go up k places. If I see a plus, I'm going to go down. And this is always places from the origin, okay? So when we say we're going to move that many places, that's from the origin or 0, 0. At the end of every equation will be just a number. And that number is the quantity r squared, and we take the square root of it to find r, just the radius of the circle. Okay. I do want to make sure I point out too what I have over here in the margin. The center of the circle is this point HK. And that's, you can either think of it as moving from the origin or you can go straight to that point HK. The big thing you need to notice is because in the standard equation it says x minus h and y minus k, your center's always opposite the signs from the equation, what you think they are. They're always opposite, and that's going to be important as we go through here. And I'll tell you right now, I put this same equation at the top of your homework worksheet because if you understand this equation, you can find all your answers or put all your answers back into this equation to do all your homework tonight. This equation is the key to the entire section of notes today. So let's check it out. Let's try to go through these examples and see what we need to do with the equation or how we write the equation. So on example 1 here, it tells us to write the equation of this circle shown. And so there's two things we need to write an equation. We need to know a center and we need to know a radius. So when you get to your homework today, those are the two things you're looking for. If you know the center and the radius, you're ready to write the equation. So I look at my circle. It looks like when I go from this side to this side, up and down, it meets right there at that center, which is the origin. So it looks like my center right here is 0, 0. Okay, and I'm going to write it over here too so you can see this. That means my h is 0. That means my k is 0. The radius is how far did I go from the center. One thing to always watch for is the scale of your graph. This one has a scale of 1, which means every line on there is equal to 1. Be careful. If the scale is 2 or 3 or something, then each line could mean more than what it looks like. All right, so from the center out, it looks like I go 2 spaces. So it looks like my radius is 2. All right, now, because our h and k are 0, we know we don't have to plug in a 0. So they just went ahead and said x squared plus y squared equals r squared, and all they're plugging in is their r of 2, and they said x squared plus y squared equals 4. Now, I do want to take a break and say if I had x minus h squared plus y minus k squared equals r squared. If I plug in my x minus 0 for my h, my y minus 0 for my k, and my 2 squared, you'll notice here when I simplify, I'm down to x squared. Y minus 0 is just y, so I get y squared equals 4. So I get the same thing whether I plug it into the h and k or whether I just ignore it since they're both 0, 0. I'm going to be honest, on your homework, I don't think I ever used just 0, 0. Maybe once. So make sure you're ready to plug in that center. All right, let's check the one beneath this. And once again, I'm going to stress here right away, look at the scaling. Notice here that your scale is 2. Okay, so that's going to make a difference. Now, when we find the center, it's not going to make a difference. I go from my top straight down, I go from my side over, and it looks like the center right there is definitely 0, 0 again. So once again, I find my center at 0, 0, and I need my radius. Well, from the center to the outside edge, I count 3 lines, okay? But if my 3 lines are scaled with 2, that's like 3 times 2, so it looks like my radius is going to be 6. All right, so I'm plugging them in. I get x minus my h, which is 0. I get y minus my k, which is 0. And it equals my r squared, so 6 squared. When I simplify, x minus 0 is just x. I always have the squared though. Y minus 0 simplifies to y, and it's squared, equals 6 squared, which is 36. And I will say, I do want you to square out those numbers when need be. If you're leaving them in the center, that's fine, but that r squared, please do the math on that one. All right, let's turn the page and see what else they have for us. All right. They're highlighting at the top of the page here that standard form equation, again, like we went over on the vocab. The standard equation of the circle with center hk and the radius r is x minus h squared plus y minus k squared equals r squared. Okay, I have an example right to the left that I want to look at. I have x minus 7 squared plus y plus 1 squared equals 25. If you know your standard equation, you should be able to interpret, kind of get from it, the center and the radius. So from the center, I want my hk. Well, h comes from my x. Sorry about this. Don't know where I'm going here. X comes from my, h comes from my x, and k comes from my y. And they're always opposite the sign I see. I see minus 7, so I go opposite that. It's going to be positive 7. I see plus 1, I go opposite that. It's going to be minus 1. So my center is 7, negative 1. My radius always comes from over here, but this is my radius squared. So I'm going to take 25 and take the square root of it. I get a radius of 5. I'm going to throw this extra in here because I do this on the homework as well. If your radius is 5, what's your diameter? Well, don't forget, diameter is 2 times the radius, so if I do 2 times 5, I get a diameter of 10. Okay, so make sure that you're just watching carefully, opposite the signs, and square root whatever the radius squared is. All right. We have some, like this example 2 in your homework. That's how simple they are. It says write the standard equation of a circle with the center at 0, negative 5, and a radius of 3.7. So h is 0, k is negative 5. I plug in for h, x minus that 0. I plug in for k, y minus a negative 5. And in for r, I'm going to plug in 3.7. Well, when I simplify, x minus 0 is just x, and I leave it squared. Y minus negative 5, a minus a negative becomes a plus. I get y plus 5. Notice I leave my parentheses, and I keep a square out there. I don't have to FOIL that out. You don't have to do anything. It looks like the standard equation, so leave it in that parenthesis just like it is. 3.7 squared, I could use a little calculator help here. 3.7 times 3.7. And I believe it comes out to about 13.69. So there's my standard equation of that circle. All right, so let's move down here. One of my favorite type of equations or problems, and so you can definitely figure, you'll probably see one on your homework and on your test next week. I have the point negative 3, 4 that's on my circle out here, and I have a center at negative 1, 2. It says write the standard equation of the circle. Well, I know I need 2 things. I need a center and I need a radius. So if you think about it, I need a center and I need a radius. I know my center already. They told me it's negative 1, 2. That means I already know my h and my k. They did not tell me my radius. Now, normally when I give you these notes, you can't see all these words in the margin yet because I didn't push that magic little button, but with these notes, you've already read this, hopefully, at the sign. It says if you know a point on the circle in the center, use our very favorite distance formula to find the radius. I have a point in the center, I have a point on the edge. My radius is how far apart they are, so I need the distance. All right, so I am going to use the points -3, 4. And -1, 2, and I'm going to find the distance. Remember, it might have been a while, but I like these on there to remind you of this. -3 minus a -1, subtract my x's, subtract my y's, 4 minus 2. Well, minus a negative becomes plus, -3 plus 1 becomes -2 squared. 4 minus 2 is 2 squared. Always square before we add. -2 squared is 4, 2 squared is 4. 4 plus 4 is 8, so I have the square root of 8 for my radius. And I'm going to be honest, I don't want to break it down, okay? And when you see what we need to do with it, this is actually easier. Just leave it the square root of 8. Okay, I needed two things to be able to write my equation, my circle, the center and the radius. I now have both. So I'm ready to go. My h is -1, my k is 2. So x minus my h of -1, y minus my k of 2 equals my radius, which is the square root of 8 squared. It's simplifying time. Minus a negative becomes plus, so I get x plus 1 squared. Y minus 2 doesn't simplify. And this is where it's really nice. The square root of 8 squared, well, the square root and square cancel each other, and we're left with 8. And there's the equation of my circle. X plus 1 squared plus y minus 2 squared equals 8. All right, before we move on, I have one more here in the margin that I want to look at. When finding a radius from the equation, put it in simplest radical form, no decimals. I have one like this on your homework, so I'm going to be looking for that. Please don't put decimals. Please put your simplest radical form. All right, just for practice, if I look at this equation, what is the center of this circle? Opposite what I see with the x, opposite what I see with the y. So my h is -5, my k is 3. For my radius, I always take the square root of that number at the end, that r squared, so I take the square root of 18. That is not a nice perfect square root, but I can break it down into 9 times 2. Square root of 9 is 3. Square root of 2 is ugly, so I leave it in. And there's my radius now. I'm going to leave it in simplified radical form, no decimals. All right, moving on to the third page. All right, this time we're going to start with an equation, and we're going to graph the circle. Just like when we need to write the equation, when we need to graph it, we need to know two things. We need to know the center of our circle, and we need to know the radius. Once we know those, we have enough information to graph. All right, so once again, I look at my equation. I have x minus 2 squared plus y plus 3 squared equals 16. They split this plus 3 into minus and -3. If you want to think about minus my h minus my k, that means my center is opposite those, so 2 and -3. So I have a center of 2, -3. Now be really careful here on this graph because it is scaled. So 2 is 1 space in, -3 would be 1.5 down. So it's kind of right there in that center spot, okay? I have an r squared of 16, so if I take the square root of 16, I get a radius of 4. So when you go to graph these, I don't expect you to get a compass out. I don't expect this to look perfect. I'm going to be looking for a couple things. If you think about it, you should be able to go 4 to the right, which will be 2 spaces, 4 to the left, which will be 2 spaces, 4 to the above, which is going to be 4 spaces but in the middle, and 4 below, which again is going to be in the middle. And do your best to connect them, okay? If it's not a perfect circle, that's okay, as long as I can see that you really attempted to hit those 4 points, 2 above and below, and to the left and right. All right, moving on to some more examples here. And again, the more you know your equation, the easier these become. I'm going to just write myself this margin note here so I don't forget it. It's x minus my h squared plus y minus my k squared equals my r squared. So it says write the standard equation of a circle with center at -3, 5 and radius of 6.1. Those are the two things I need to write an equation, the center and the radius. So I'm ready to plug and chug. So I'm going to do x minus my h, which is -3. That's my first thing. Squared plus y minus my k, which is -5, squared equals my r squared, which is 6.1 squared. Cleanup time, minus a negative becomes plus, so x plus 3 squared. Y minus a -5, clean that up, I get y plus 5 squared. And 6.1 squared, another calculator problem, 6.1 times 6.1. Please don't do 6 times 6 and 1 times 1, that doesn't make it work. 6.1 times 6.1, and our calculator says about 37.21. Now I'm going to be honest, if you can look at this and go straight to the equation, you don't have to show this middle step of work. I'm showing it to you so you can see where I'm finding the plug-in and where I'm going to it, but if you're feeling comfortable, jump right to that answer. All right. The point -1, 2 is on a circle, and there's a center of 3, -3. Write the standard equation of the circle. We need two things, a center and a radius. I have my center here for my HK. I do not have a radius. To find the radius, I'm going to need to take that distance formula again. A point on the circle is -1, 2, and when you take that point to the center of 3, -3, we get a radius. So I'm going to find the distance between those 2 points, subtract those x's, -1 minus 3 squared. Subtract those y's, 2 minus 3 squared. -1 minus 3 becomes -4. 2 minus 3 becomes -1. Remember, when we square things, all the negatives go away because -4 times -4 is +16. -1 times -1 is +1. 16 plus 1 is the square root of 17. It looks ugly, but we're not too worried about it. And something tells me I just made a mistake. I did. All right, let me try this one more time. I'm going to erase about half of my work here. All right, let me try this one more time. I dropped my negative here on that second 3. It should be 2 minus -3. Minus a negative becomes plus, so that's going to become 5 squared. All right, -4 times -4 is still 16. 5 times 5 is 25. And 16 and 25 will make 41 for my R. Okay, I got distracted there, but now at least our math is right. Make sure you realize that you don't have to simplify this. We actually like it in the square root, so leave it just like that. It'll do well when we go to plug and chug now. Coming back to our problem, we're writing the standard equation. So I'm going to start with x minus my h is my 3, squared plus y minus my k, which is -3, that I almost forgot earlier, squared, equals my r, which is the square root of 41, squared. Cleanup time, x minus 3, nothing has to happen there. I leave it x minus 3 squared. Y minus a -3, I'm going to make that a plus, and I get y plus 3 squared. And the square root of 41 squared, the square root and the square cancel, and I'm left with 41. So when I get done, it looks like a nice, pretty problem, and there's no radical there. Make sure when you're doing that type on your homework that I can see that distance formula being worked out. All right, next one is a graphing one. Just like when we go to write the equation of a circle, when we go to graph the equation of a circle, I still need two things. I need to know my center, and I need to know my radius. This time I'm looking at the equation that's already written and find my center. My h comes from here, my k comes from here, always opposite the sign that you see. So if I see a +2, my h is going to be -2. If I see a -1, my k is going to be a +1. So my center's at -2, 1. So I come to my graph, -2, 1, there's my center point. I see my r squared is 9. Since r squared equals 9, I take the square root of it, and my r is going to equal 3. So I have a radius of 3. That means 3 to the right from my center, 3 to the left from my center, up 3 from my center, and down 3 from my center, and I end up with a circle of radius 3. All right, we're moving on to page 4. Kind of one of my favorite pages on this section. Shows you a little bit of real life, what you could do with this. Of course, this example maybe not is as real life as some, but we can kind of relate it to real world problems. So we have a time capsule that has been buried in your yard. And of course, most of you have your yards in grids, I hope. You know, you've already decided where your origin is, and then you have, 1 foot sections out from there. If not, you could get busy on that while you're at home right now and grid out your yard so you can practice these, right? So you're going to bury a time capsule and use a grid to write directions for finding it. And we're going to use the following measurements to find the burial location of the time capsule. All right, so it says that we're using an oak tree at 0, 0, or the origin. So here's my oak tree right here, and it says that this capsule is about 11 feet from the oak tree. Now the question is, which direction 11 feet? Quick reminder here, I do want to tell you, is we do have a scaled graph. It looks like it's scaled by 4s, okay? So maybe it's 11 feet straight up. So here's 4, 8, almost to that line. So we're right beneath that line. Maybe it's to the right. So again, almost to that 3rd line. Maybe it's down, almost to that 3rd line. Maybe it's to the left, almost to that 3rd line. So really it can be in any direction from that oak tree, which kind of means, as I kind of make a line here, I think my time capsule is somewhere within this circle that's all 11 feet from the oak tree. Okay, it's 0 and I went a radius of 11. So that was my first one. Okay, change colors here so we can stay organized. My second clue says the time capsule is 8 feet from the flagpole, and the flagpole is at B, which is 0, 8. So 0, 8 starts, that means none to the left or right, and up 8. So there's 0, 8 for my center. And this one says the capsule's 8 feet from there. So it has a radius of 8. Now remember, each line is 4. So I'm going to go either 8 feet to the right, which is 2 that way, 8 feet up, which is 2 that way, 8 feet down, which is 2 to the bottom, or 8 feet to the left, which is 2 that way. So kind of in this set of circles now. So now it's somewhere within this red and green section here. All right, one more clue to kind of narrow it down. It says the capsule is 4 feet from the mailbox, and the mailbox is at negative 12, 8. So I'm going to go to negative 12, 8 for my center. So negative 12 would be 3 lines to the left. Positive 8 would go up. Okay, so there's my center of negative 12, 8. And this time I have a radius of 4. Well, that's just one line on my graph. So I can either go 4 up, 4 to the left, 4 to the down, 4 to the right, and I make my circle here as best as I can. And the question is, where do all 3 of these clues meet up or overlap where it would match all of these? And it looks like I have this point about right here, okay, which looks like it's to the left 2 lines, up 2 lines. Every line is 4, so it looks like it's going to be at about negative 8, 8. Okay, now a quick reminder here to think of this in a real world situation. What we've just kind of done here is called triangulation. Okay, I can't even say the word right now. But this is something similar to what they might do with a cell phone tower. If they're trying to locate people, is they will ping them off of cell phone towers. So if this cell phone tower here says it hits the phone 11 miles away, we could say, and this cell phone tower says it gets a ping that's 8 miles away, and this cell phone tower gets a ping that's 4 miles away, they can triangulate that all together and find out that, oh, maybe right in this position is where that cell phone is located. So again, it seems kind of silly on this time capsule type problem, but it really is a real world application that they can use, especially with technology we have nowadays, to be able to figure out where things are located. 3 measurements can definitely triangulate and find out where we're at. All right, moving on to the bottom here. Not much to do here on the bottom. It says, in example 4, suppose your mailbox, it was at positive 12, 8. So if I went to positive 12, 8, I would be over here on the right, and they said 4 feet away, and I did this little circle, then we would move it, and it would be positive 8, 8, because that would match all three of them. So not a lot different on that one. Makes my picture look kind of funny, though, now that I look at it. Okay, I do have one more page of notes, one more type of problem I want to look at, so let's go to the last page. And this is deciding by an equation where some points might lie on the graph with it. Now, I do know some people like to take this problem and say, well, let's just graph this circle and then see where these points are. But I'm going to be honest, I just told you I don't need you to use a compass to draw these. So sometimes our graphs are a little bit distorted and not quite positive where points lie. So what I really want you to do is use the algebra on this, and that will be the most accurate way to do these. So it says describe whether the point lies on, in, or outside the circle described by this equation. Okay, so I have this equation. We can graph it because we know how to graph it. It has a center of 2, 6, has a radius of 5, but we have these 4 different points. Do they lie inside the circle, exactly on the circle, or are they outside the circle? So here is our set of notes that will tell us this, okay? So when you do your homework, the last 3 on your homework sheet, you'll need these notes. And when you do your test next week, you're going to have one too, so you're going to want these notes handy. So here's kind of the quick note, and then as we do the examples, it'll make more sense. It says if the points are on the circle, we're going to find that we're going to equal the radius squared. If the point lies in the circle, we're going to be smaller than the radius squared. And if the points are outside the circle, we're going to be greater than the radius squared. Okay? Now, a little vagueness here, like what equals r squared? What is smaller than r squared? What is greater than r squared? Well, let me show you what this is. I have an equation of a circle, a standard equation, and I have a point. Don't forget, every point symbolizes an x and a y. That's what those 2 points work for. So what I'm going to do is take my equation, and instead of x minus 2 squared plus y minus 6 squared, I'm actually going to plug in my x of 2. 2 minus 2 squared. I'm going to plug in my y of 6. 6 minus 6 squared. 2 minus 2 is 0. 6 minus 6 is 0. 0 squared is 0 plus 0 squared is 0. I get the number 0. When I have this point and I plug it into the math, I get 0. 0 is definitely less than r squared. Since 0 is less than r squared, which is 25, I'm going to be in the circle. So this one is definitely in the circle. And if you stop and think, it makes sense because 2, 6 is the center of this circle. So it makes sense that that's the math that we got. All right, let's try this next one. I have 5, 10. Here's my x, here's my y. So I'm going to plug in for x, I'm going to plug in 5 minus 2 squared. For y, I'm going to plug in 10, and then it's minus 6 squared. 5 minus 2 is 3. 10 minus 6 is 4. 3 squared is 9. 4 squared is 16. 9 and 16 makes 25. And that's exactly equal to 25. It equals my r squared over here. Since it's equal, that means that I'm exactly on the circle. Okay, that means this point 5, 10, if I graph this circle, would be 1 point on the outside of that circle. All right, let's try the next one. I have the point 4, 2. So once again, there's my x, there's my y. So I'm going to plug in 4 for my x. 4 minus 2 squared. I'm going to plug in my y, so 2 minus 6 squared. I'm going to check my math. 4 minus 2 is 2 squared. 2 minus 6 is negative 4 squared. That gives me a 4 plus a 16, which is 20. Well, 20 is smaller than 25. Since 20 is smaller than 25, that means that once again, I have to be somewhere inside the circle because I'm smaller than the radius squared. I should say smaller than the radius squared. All right, one more to go. 6, 9, so I'm going to plug in, for my x, I'm plugging in 6 minus my 2 squared. And plugging in for my y, I'm going to do 9 minus 6 squared. 6 minus 2 is 4 squared. 9 minus 6 is 3 squared. 4 squared is 16, 9 squared is, 3 squared is 9, sorry, my brain's ahead of me there. 16 and 9 is 25, so once again, I get equal to, and that means I have another point that is on. So I didn't even end up with one of these being out, but if so, I would have gotten a number larger than 25. So that's how we check to see if a point is in, on, or outside the circle, and you will see a couple of those on your homework. So once again, a homework worksheet, please, please, please show your work. I would stress writing down the center and the radius every time because those are the two important things. And then on these final 3 problems on your homework, make sure you show me the work for how you know if it's in, on, or outside the circle.